Alright, welcome back guys. We're going to look at how we can use matrices to represent information as a way of storing information or data. Okay, and then we can perform some operations with those matrices. Alright, so previously we looked at how to add and subtract matrices, how to scale a matrix, or in other words, multiply a matrix by a scalar, which is just another number. And so now let's look at example 3. We'll actually get to apply a little bit of what we've learned. Okay. So it says Waterworks Incorporated manufactures 3 types of kayaks in its 2 plants, and the following table lists the number of each style produced at each plant in April. Okay. Well, this table here, guys, or the data, the information that's contained within this table is itself a matrix, right? Because it's got some rows and it's got some columns. Now, the rows here actually represent the 2 different operating plants, Madison plant, Greensburg plant, and then the columns actually represent the different types of kayaks that are manufactured at these 2 plants, okay? And so part A of this question says just simply construct a 2x3 matrix, we'll call it A, that represents the information in this table. Well guys, it's right here. This is your matrix, okay? It has 2 rows and it has 2 columns. So we're going to, we'll go ahead and write that A is equal to, and then we'll input these entries. These are just the respective numbers of kayaks produced at each of these 2 different manufacturing plants in the month of April. Okay, so that is part A. That is our matrix. That contains the information from this table. And then part B, it goes on to say, the manufacturer increases production by 20% in May. Okay, so we want to find a matrix M that represents the increased production figures. So in other words, guys, if we're increasing production by 20% in May, these figures here need to increase by 20%. Okay, so M, or the matrix that represents the increase, is going to be 20% of whatever these values are. Okay, and so essentially what we're doing here is we need to figure out what 20% of all these previous values are. Okay, or in other words, 20% of those values stored in matrix A. In other words, we need to multiply matrix A by the scalar 0.2 or 0.20. Okay, and that's what this comes down to, just multiplying A, which contains our original figures, by 20%. And remember, 20% as a decimal is 0.20. Okay, and so if we were to do this, this would be 0.20 times, I'll go ahead and rewrite matrix, the entries for matrix A. Okay. I think these problems are pretty neat, interesting. Alright, and so we're just going to multiply all of those figures by 0.2. Okay. Some of this I might do in my head, guys, if that's okay. 20% of 150 is 30. But you could just do this in your calculator. 20% of 120, I believe, is 24. 20% of 100 is 20. 20% of 180 will be 36. 20% of 90 is 18. And finally, 20% of 130 is 26, I believe. Okay. Basically, all I was doing, guys, is 10% of these figures would basically be like throwing the zero away. So 10% of 150 is 15. Well, 20% is double 10%. And so if you double 15, you get 30. So that's what I was doing with all these. 10% of 120 is 12, and if I double that, I get 24. So that's how I was doing that. But you can check these, you know, in the calculator. You can do that. You know, you just type in here 0.20 times, and then each of those figures. So 150, you get 30. Okay. All right. So this is matrix M right here. This is the increase in volume that's going to occur in the month of May, in addition to the number that they were already producing. They're going to increase by this much. And so part C says, find the matrix A plus M and tell what it represents. Okay, so in other words, and I should have written this a bit more concisely, but what we want to do is add matrix A to matrix M. Okay, well, matrix A is the original production figures for April for these three different types of kayaks. Let's see, 100. Okay, and we're going to add to this the increase in production. That's what matrix M represents. So 30, 24, 20, 36, 18, and 26. Okay. Now when we add these two matrices together, we'll get a new matrix. It'll have the same dimensions. It'll be a 2 by 3. But the significance of it, or what it represents, will be the actual numbers of kayaks produced in May. Okay. Not just the increase in production, but the actual production figures. All right, so if we were to add these, 150 plus 30 will be 180. 120 plus 24 will be 144. 100 plus 20 is 120. 180 plus 36 will be 216. 90 plus 18 is 108. And then finally, 130 plus 26 will be 156. Okay, so this matrix represents the actual numbers, or the actual number of kayaks, of those three different kayaks produced from those two specific factories in the month of May. Okay. All right, so you've seen an example in which we can use matrices to represent some information and also do some arithmetic with those matrices and have it be meaningful. Okay, so now the next thing we're going to talk about is multiplication. So we've looked at, we may be saying, well, didn't we already do this? Well, we looked at scaling a matrix, or multiplying a matrix by a scalar. But what about if we wanted to multiply two matrices together? How does that work? Well, turns out there is a condition in order for that to even be possible. Okay, and I've got it written here in the notes. So let's say we've got these two matrices, A and B. They can only be multiplied if the number of columns in the first matrix is equal to the number of rows in the second matrix. For example, a 2 by 3 matrix can be multiplied by a 3 by 4. And the reason is because the number of the number of columns in the first matrix matches the number of rows in the second matrix. Okay? So in other words, if you write the dimension of each matrix, the two inner numbers have to match. And then the resultant matrix will come from the two outer numbers. It will be a 2 by 4 matrix. Okay? So guys, if those two inner numbers don't match, then multiplication is not possible. Now, multiplying matrices is a bit demanding from arithmetic perspective, and so consequently we're going to multiply matrices using the calculator. Okay, there's a lot of well, for example, what you have to do, well, let's just look at example 4 and talk about it for a minute. Okay, so it says example 4, it says for matrix A, and it gives matrix A, let's go ahead and identify the order. It is a 2 by 3, okay, 2 rows, 3 columns. And matrix B, it is a 3 by 2. Notice it has 3 rows and 2 columns. And it says find the following if possible, multiplying A times B and then B times A, okay. Well, A times B will be possible. And the reason is because A is a 2 by 3, and we want to multiply it by another matrix that's a 3 by 2. Well, those two inner numbers match, and so the resultant matrix will be a 2 by 2. Okay. Now, we're going to do this in the calculator, but I will say if you were going to do it by hand, you have to take the first row of your first matrix and pair it up with the first column of the second matrix. So you essentially have to say 3 times 1, 1 times 3, negative 1 times negative 2. And from those 3 products, you add all those 3 products together, and that gives you the first entry. Okay. And then you stay on this same row, and you do it to the next column. Okay, so 3 times 6 plus 1 times negative 5 plus negative 1 times 4. Do all that. That gives you your second entry of the first row of your resultant matrix. And then you move to the second row and do the same thing. Okay, so it's a lot of operations. So we're just going to rely on the calculator. Alright, so let's turn it on again. We're going to go to our matrix screen. We'll come over here to edit. And we want A to be a 2 by 3. We want A to be a 2 by 3. Okay. And we'll input these entries or values. 3, 1, negative 1. And then in the second row we've got 2, 0, 3. So that's matrix A. I'll go back to my matrix screen, go over to edit, and go down to B. And B is a 3 by 2. Well, I've already got 3 by 2 in here, so I'm good there. I just need to input these new entries. 1, 6, 3, negative 5, negative 2, and 4. Okay. So now we'll quit this screen, and now we just need to tell the calculator to literally multiply A and B. So you go back to our matrix screen, we just grab A. You don't even have to say times here. Go back and grab B, hit enter, and look, we get a 2 by 2 matrix, don't we? Just like we said we would. So let's copy down these entries. 8, 9, negative 4, and 24. Okay, now we'll put in here in the notes from the calculator. You can do it by hand if you want, guys. The book will show you how, or the viewing example will show you how, but like I said, it's very tedious and it's a lot of work. Okay. Now let's see if we can actually do the reverse. B times A. Well, what are the dimensions of B? B is a 3 by 2, and A is a 2 by 3. Okay. So this will still work because these inner numbers match, but our resultant matrix will be those outer numbers. It will be a 3 by 3. Okay. So you can already see that A times B is not going to be the same as B times A. These are going to be completely different matrices. And lots of times, guys, you may be able to multiply A times B, but B times A won't even be possible, okay, because of the dimensions. So you can see that property of commutativity that I mentioned in the part 1 video applying to these matrices. All right, well, let's go ahead and input these new matrices. So A is a 3 by 2 now. Well, actually, you know what? I'm not sure why I am doing that. Let me see if these entries stayed the same. 31, they didn't. Guys, you didn't need to do that. A and B are already in there. So just turn around and instead of multiplying A times B, just put B times A. So, yeah, that was stupid on my part there. So, anyway, let me just rewrite A. Okay, I think these entries are 2, 0, and then we need a 3 over here. Okay. Alright, so let's pretend that that never happened. Okay. Alright, so now what we can do is go back to our matrix screen, but we're going to multiply B first and multiply it by A. Okay. And let's see what we get. In fact, we get a 3 by 3, don't we? Okay, so we'll copy down these entries. 15, 1, and 17. And what else? Negative 1, 3, negative 18. Two, negative 2, and 14. Okay, and again, we did this in the calculator. All right. If the dimensions don't match, guys, and you can't do it, but you try to do it anyway with your calculator, you'll get an error. It'll say dimension mismatch. Okay, so just be aware of that. That just means that it's not possible to multiply those two matrices. Alright, we're going to look at one more in the notes, and then I may decide to do a little part 3 video in which I do a homework, 1 or 2 homework examples. We'll see. Just to give you a little extra. Alright, example 5 here. It says, 2 of the items sold at Sweet Treats Bakery are gluten-free bagels and gluten-free donuts. The following table lists the number of dozens of each product that are sold at the bakery's 3 stores 1 week. Okay. Alright, so in these 3 different columns represent the 3 different stores, and then the 2 different rows represent whether they're gluten-free bagels or gluten-free donuts. And so this 25 here, this means 25 dozen. Okay. At the Main Street store, and 40 dozen donuts at the Main Street store. And then the same thing similarly for Avon Road store, Dalton Avenue store, etc. Okay. All right. So it says the bakery's profit for 1 dozen bagels is $5. Okay, so for each dozen that any of these bakeries sell, they profit $5. And then the profit on a dozen donuts is $6. So we want to use matrices to find the total profit of these items at each store for the given week. Okay. Well, we're going to have to use we're going to end up multiplying 2 matrices. Now you could intuitively think, well, if they're making $5 for each of the bagels, couldn't I just multiply each of these numbers here by 5? The answer is yes. Furthermore, they're profiting $6 for each dozen donuts, so you could just multiply each of these entries by 6. Or you can look at this from a matrix perspective, and we can say, let's see, let's let matrix A be the numbers of dozens of donuts and bagels, or I said it back in the reverse order, bagels and donuts sold at these three different bakeries. Okay, so this would be the matrix that represents the numbers sold. Now we can come up with another matrix that represents the profit. Okay, so I'm going to let P for profit, be another matrix, and guys, I'm going to let it be a 1 by 2. You'll see why here in a second. The first entry is going to be that for, I think I need it for bagels, yeah, $5 for bagels, and then the second entry is going to be $6 for the donuts. Now, if I multiply these correctly, the end result, first of all, let's write the dimensions here. A is a 2 by 3 matrix, and the way I've constructed P, it is a 1 by 2. Okay, you can play around with P. You can make it a 2 by 1, but only will this variation, it being a 1 by 2, actually allow you to multiply them. And the reason is that you'd have a dimension mismatch. Okay. And so what you'll do is you're going to take the profit matrix. Well, I'm starting to run out of room. Let me be careful a little more. You're going to take the profit matrix, which is a 1 by 2, and multiply it by what could we call A? The matrix that represents the number of items sold. Okay, like the product matrix. In other words, it is a 2 by 3. And now you notice that those inner numbers match. Okay, that's why I wanted P to be a 1 by 2 and not a 2 by 1. And so if we multiply these, we'll get a result that will be a 1 by 3. Okay, again, those outer two numbers are 1 by 3. And that 1 by 3, guys, will represent the profit from each of these 3 stores for that week. Okay, all right, well, let's, I'll go ahead and write out each of these matrices explicitly. So 5, I don't know why I put a comma in there. 5, 6, and then we're going to multiply this by matrix A. Okay, and we'll end up with a 1 by 3 matrix. Now think about this. If you were to do this by hand, what you'd be doing is you would take this row and pair it up with this column. So you'd be multiplying the 25 by 5 and adding it to the 40 times 6. So that entry that you get right here will be the profit from both bagels and donuts sold at the Main Street store. And then you would take this same row and pair it up with column 2. And that'll give you the profit from the Avon Road store. Okay? So anyway, let's go ahead and do this. Okay, we'll go to our matrix screen. Now, of course, you could scroll down, but guys, you don't have to have a P. Okay, we can just let matrix A be our first one with our 1 by 2. And matrix B can be our second matrix, our 2 by 3. Okay, so as long as you remember that. So I'm going to edit this. I want this to be a 1 by 2. Now I've got 2 entries, the profit from the bagel, from each dozen bagels, and the profit from each dozen donuts. Okay, so I've got that matrix. Let's go back to edit, go down to B. This is our second matrix. This needs to be a 2 rows and 3 columns. And then we need these entries, 25, 30, 20, 40, 35, and 15. Okay. Now we'll quit this screen, and I'm going to say A times B, which represents P times A that I have right here. Okay. I could also, maybe I should have used an N instead of the A, just for number of bagels and donuts. So let me actually do that real quick. Place the A with N. Because you'll see in the homework we'll be using different okay. There we go. Alright, well so we're back here, so let's just grab the first matrix and we'll multiply it by the second matrix, and we're going to get a third matrix, and look, it is a 1 by 3. And these entries represent the profit from each of these stores. So guys, hopefully now you're starting to see the real utility in these matrices. See, you could have done all this, you could have figured this out intuitively, right? Just multiply all 3 of these numbers in the first row by 5, all 3 of these in the second row by 6, add together, and you get the profit from each store. But if you approach it from a matrix perspective, then this becomes a much easier task. But in any case, let's go ahead and record these entries. And these are going to be in dollar amounts as well. Make sure I've got enough room. 365, 360, and 190. Okay, 190. And so, like I said, this would be the profit. This is the profit from each of those 3 stores. So this would be, Main Street. This would be Avon Road, and this one would be the store on Dalton Avenue. Okay. All right. So hopefully that makes sense. And I think I may do a part 3 in which I do 1 or 2 examples from the homework. Okay, just to give you a little bit of extra practice. All right, guys. Well, I'll go for now.